7.6 deals with division properties of radicals, and we've done this already, if not mentally, but physically. That says if I have two radicals, as long as they're same index, I can write them as 1. And we've done this already when we were simplifying radicals. If we have one radical, and we can write them as 2. That's all this is about. The key to doing a 2 radical problem, especially if, like this guy, the radical is not a perfect square, is what you want to do is you want to write it as 1, reduce it. So essentially what you want to do is to rewrite and reduce. That's going to make your life a heck of a lot easier. So you write it as a single radical. So this is 30y to the 5th over 10y. And what you have is that 10 divides 30 3 times. And then notice the denominator is going to make it a y to the 4th. So this is going to turn into the square root of 3y to the 4th. Notice how nice that is. So if I were to look at writing it as the perfect square and the leftover, the square root of y to the 4th is y squared, square root of 3. The downside of this book is that a lot of the problems are just plain icky. They just are. And I hate to say this, is that some of you have already brought, Sarah in particular, you brought an error to my attention. There are tons of them in this book. Tons. I was talking to, Miss Norris, Kim Norris, on Friday, and her students are finding a ton of errors. So that gives me something else to complain about. Well, which I will. If I'm not happy with the book anyway, and there's a ton of errors, So notice the 5 is on the outside. So when I think about this problem, it's 5 times, and then the radical is going to be 54y to the 7th over 2y. This is going to be a cube root. 2 divides 54, that's going to be a 27. Y to the 7th, that's going to be a 6. So this turns into 5 times whatever this becomes, which is 27y to the 6th, a cube root. And that's a perfect cube. How convenient. That's what I mean. Bring it under a single radical, reduce it first. So this becomes 5 times, cube root of 27 is 3, of y to the 6th is y cubed, y squared, sorry about that, and so this is 15y squared. I don't like this one. Why do you think I don't like this one? That dang negative exponent. Well, it is a 4th root. So it's 48 a to the 9th b over a b to the negative 3. And what do I need to do with the b to the negative 3? Take it to the top. Now, a removes one of the 9 a's. That's going to give me an a to the 8th. And so this then becomes the 4th root. And of 48, a to the 8th, b times b cubed. Because I can take that b to the negative 3, move it up.
Is it 4?
It's going to become a 4,
Oh, okay.
which is the 4th root of 48 a to the 8th, b to the 4th. Oh, is that not the cutest thing you ever did see? The 48, not so much. Which is the 4th root. 48 is 4th root 16 and 3. A to the 8th is a perfect 4th, and b to the 4th is a perfect 4th, because the exponents are divisible by 4. 4th root of 16 is 2. A to the 8th is a squared. B to the 4th is b. And 4th root of 3. See what I mean? Unpleasant. Not particularly much fun. Tedious. What I want you to remember is this, because you guys like to rush through things. If you find when you're making errors that by rushing through, you slow down, you put in the extra step. Then when you're more confident, you can rush through a little bit faster. But these things are not, they're complicated enough. Rushing is only going to cause you issues. Now, when I take a look at this guy, I notice that I can reduce the x's. So I reduce first. And I can reduce the 6 and the 27. So that 3 divides 6 twice, divides 27 9 times. And this takes out one of the 5 x's, which leaves me with an x to the 4th. So in the end, I have a 2 left over by itself in the numerator and a 9x to the 4th in the denominator. And what you notice is the denominator is a perfect square. So it's the square root of 2 over the square root of 9x to the 4th. Square root of 2 is the square root of 2. Square root of 9x to the 4th is 3x squared. Reduce first before you try to break it apart. Now that's a stinking 2 multiplying that. So that says that's a 2 times, and then I'm going to mess with the radical. I notice that the 3 is not a cube, x to the 6th is a cube, 8 is a cube, y to the 9th is a cube. So that says I can actually take these guys and then write them separately. Cube root. That's a y to the 9th. This becomes a 2 times, well, the numerator, 3 is not a cube, but x to the 6th is. This is an x squared, cube root of 3. The denominator is a cube. Cube root of 8 is 2. Cube root of y to the 9th is y to the 3, right? And then you notice this is a 2 over 1. The 2's will actually reduce out, because that's all multiplication. So this becomes an x squared, cube root of 3, divided by y cubed.